Hello friends, welcome to my channel, a channel for learning simple coding. If you find this video to be helpful, please like, share and subscribe my channel. In last video we have seen what is variable, how to declare mutable or immutable variable in Rust. Now in this video we are going to learn the various data type supported in Rust, and we will see the example of that also. And what is data type? Everybody know that the data type is the type of value that variable is stored. So we go to the documentation here, official documentation of Rust, and here you see that data type supported in Rust. So they are scalar. Scalar means the which stores single value, and compound data type means array and tuple like of variables. So we have here integer types of variable. Remember that we have 8-bit, 16-bit, 32-bit, 64-bit, 128-bit or architecture default arc. So how to declare? If there is a sign, integer sign means negative and positive both value you can store. Then we have i8, i16, i32, i64, i28 or iSize. iSize is default as per your architecture. Similarly, if you are using a sign integer, means you don't want to store negative value, then we have a u8, u16, u32, u64, u128, usize. So this way you can declare integer variable. So we take example here. Remember, so I just came out from this, and once again I create a new package in cargo. I say cargo new, and I say class number 6, and I say data types. So we have this. I go inside this class 6 like this, and I close it, and I open the class number 6 file, this one, and here I define a variable. I say let num1 of, I say I 128-bit of variable, and I define this. I say this value. Remember this. And now I give here the value of num1 equal to, and we have this curly brackets, and inside this I put num1, and this I am specifying a data type here. If I say cargo run, and you will see the output, this is this. So by default, if I remove it, by default type is i32. Remember that. If I run it, no change in display, but the by default value is 32. How you can check it? 32 range. If I give a big value more than the size of a 32-bit, maybe it generate error. You see, we having error that this is out of the range of i32. Remember that, because by default size here is i32. But if I say i64, I specify here i64, putting a colon here. Now you see it is the size of this or not. You see it is also huge size, greater than i64 also. So here I say 128 of bit. Save this. Now try to compile it, and you see it's running now, because this is a 128-bit of size. So like this you can test that integer sizes. By default is i32, but you can give whatever you want. If you want to slice one more variable, like I say let, and I say num_p, p means positive value, not negative, and here I say u32, and suppose I say here negative value, I store negative value here, and then I try to display this value num_p here and save this, and you will see that I run it and you have a error. Error is why? Because cannot apply unary operator minus. Remember that, because the variable declaration is unsigned 32, but you are passing a signed value, so it's not possible. Remember that Rust is a very strict on this. It's a type safe language, memory efficient language. Memory safety is there, type safety is there. It's a very crucial language. It check all the error at compile time, so you can't initialize the negative value if you declare it as a positive. But you can do like this in C and other languages, but you can't do in Rust. Remember that. So you have to convert this into the positive value, then you can compile it, otherwise it will generate error. You see, similarly you may have other data type also, but we have learned now integer type. You can do this, you can check yourself. Other data types also I have explained you. Then we have the other declaration of this decimal value. You can declare like this. If you want to declare hexadecimal value, then you have to use 0x, then it will convert into hexadecimal. If you put O in the beginning, 0O, then it will belong to octa. If you write 0B, then it will convert to binary, remember. And then you have this like this. If you are using byte, so we have a U8 only for byte declaration, and you have to write B here, and then you have to put the value of this. So like this way you can declare your variables of hexadecimal, octal, binary type. You test yourself, because I am not going in detail of this, but you have the knowledge that in Rust language we have a different way to declare the variables that is not available in other languages also. Now we go to for floating value. There are two types of floating value supported in Rust, F32 and F64. By default is 64. So here if I say fnum1 floating value, and if I declare it like this, and I display this value again, so I say value of fnum here, and I put fnum like this, and you will see that on it by default size local variable similar to what is okay, that I have to remove here fnum. Then I run once again, semicolon I have to add, remove semicolon also, then run once again, and you will see that we have f34.5. remember that by default it is f64 bit. By default floating value is f64 bit. And how we can check this? So if I put here like this and I save this, and you will see the output now. You see it taking 1 2 3 4 5 6 7 8 9 10 11 12 13 14 types of decimal value after this, because it's a f64. But if I put here manually, I say f32, so you will see now output same value but in f32 format. You see now size is decreased. Remember, only we have a 6th place of decimal. After decimal we have a 6th place, but there we have the 14th place. Earlier we see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14 place of values there. Here we have a 6th place of value. So now it is f32, earlier it was by default is f64. Similarly we have other data type also, like we have boolean data type here. Boolean, everybody know true and false. By default I think there is a true, and then we have a false. We have a char also, so you can check these also. So here I say let, and I say check equal to true like this, and I can display this println like this way, and I say value of check, and here I say check like this way. And similarly I can take character also. I say name equal to single character v like this, I take like this, and I just print this value. I say value of name, and here I put name, remember, and save this. If you run it, now you will see that we have a v, we have a true. Here in place of true we can put false also, equal to false also, or you can declare like this also, bool like this way. You can declare this also, remember. And once again I compile same, but we have the new value here false. So like this way you can use various data type in Rust. Remember that Rust have a type safety, so you can't assign a wrong value in Rust variable, so you have to check it before initializing the value. So it's a very efficient programming language in case of memory and type safety also. So these are the data types supported in Rust programming language. If you like it, please do subscribe. Thank you for watching this video.